Now in the last question, you've done this example. Let's move on to the next example, which is from the year 2000. Now it says a company intends to provide a kind of weighing device as shown below. Now the device is held at point X and the position of the counterweight is adjusted until the rod AB becomes horizontal. Now the weight of the object can be measured from the scale calibrated on AB. Which of the following changes can increase the maximum weight that can be measured by the device? So number one, moving the string at X towards A. And number two, increasing the mass of the counterweight. And number three, increasing the length of the string from which the counterweight hangs. Now let's look at them one by one. So the maximum weight of the object occurs when the counterweight is at B, at a distance largest from the pivot, from the point X. Now let's look at the free body diagram of the rod. T is the tension of the string holding the device upward, and the weight of the object equal MO times G. The weight of the counter mass is recorded the weight of the counterweight recorded MC times G. Now you can see that the point of the hook is fixed so that the distance D plus E is a constant. So the first statement is correct. Now let's see why. If we take moment about X, the sum of clockwise moments should be equal to the sum of the anti-clockwise moment, and D plus E is a constant. Now let's look at it. The clockwise moment should be MC times G, and the anti-clockwise moment should be MO times G. And then moving the term GD to the other side, we get the mass of the object should be equal to MC, the mass of the counterweight, times E divided by D. So as the point X move towards A, we can see that D decreases and E increases. So the mass of the object increases. Now note that the string cannot pass the hook. Cannot pass the hook. Otherwise, it won't be balanced. Now let's move on to the next statement. What is the next statement? The next statement is increasing the mass of the counterweight. So 2 should be correct. Now we look at this statement. So E is fixed to get the largest weight, okay, at the maximum value. So DE a fixed number. So MO, the mass of the object, should be equal to MC times G over D. So as the mass of the counterweight increases, the mass of the object also increases. And then we have part C, increasing the length of the string. Well, this is incorrect. This is incorrect because if we look at the free body diagram, however long is the string, the tension got to be equal to the weight of the object plus the weight of the counter mass. But those two weights are independent. They independent of T because they're governed by this equation. So even you increase the length, the tension remains the same. Now until next movie.